You have fallen into Event Horizon with John Michael Godier. In today's episode, John is joined by Professor Avi Loeb. Avi Loeb is the Frank B. Bird Junior Professor of Science at Harvard University, Chair of Harvard's Department of Astronomy, Founding Director of Harvard's Black Hole Initiative, and Director of the Institute for Theory and Computation within the Harvard-Smithsonian Center for Astrophysics. He also chairs the Advisory Committee for the Breakthrough Starshot Initiative, serves as the Science Theory Director for all initiatives of the Breakthrough Prize Foundation, as well as Chair of the Board on Physics and Astronomy of the National Academies. He is the author of 4 books and over 700 scientific papers. He is an elected Fellow of the American Academy of Arts and Sciences, the American Physical Society, and the International Academy of Astronautics. In 2012, Time selected Loeb as one of the 25 most influential people in space.
And we're back with Dr. Loeb. Now, Avi, could you have predicted back in the day when you were working with black holes with Stephen Hawking and thinking about these very, very untestable environments inside the event horizon of a black hole, could you have predicted that you would end up a number of years later dragging the ocean floor looking for interstellar material?
No, but that's the fun of going through life. When your future is not anticipated. And I must say the surprise was very pleasant for me, because you can argue forever about theoretical ideas, but when you get something real like materials, you analyze it, it sounds much more tangible. The public responds to that much better. You know, the film Oppenheimer depicted the way Oppenheimer led the Manhattan Project. But one thing I know about Oppenheimer is that his most celebrated work is about the collapse of a star to a black hole. And he regarded that paper as being applied physics, not to be celebrated. Nothing of importance, because he wanted to focus on the glory of theoretical particle physics, where more abstract notions are being discussed. And the irony is that even though he didn't regard very highly the applied paper that he wrote, and applied, I should say, it's not applied in the sense that it's commercially useful, but more in the sense that you use the known laws of physics to explain a process that takes place in nature. In this case, a collapse of a star to a black hole. It turns out that that's the thing that is being remembered, and the reason is because it applies to the reality that we share. And obviously, black holes were discovered many times, including with the gravitational wave detector and LIGO, and also directly. But somehow Oppenheimer missed this point. He was not mature enough to realize that by explaining something real, you have a better chance of being remembered. That's the feeling I get from leading this expedition, that we have retrieved something new. These are spherules of a new type, never seen before. And it opens up the door for new discoveries in the future if we just feel humble enough to admit that there is something that we didn't know before. And of course, a lot of the experts that worked on space rocks, they tend to argue that everything in the sky must be stones, and I call that the Stone Age of science.
Now, the control areas that you swept outside of the path of IM-1, these control areas also yielded materials. And so my question is how did they differ? What do those materials look like?
Right. So in the control areas, that were tens of miles away from the path of IM-1, and also within the Department of Defense error box, there were many regions that were removed from the meteor path. In those, we found the standard type of spherules that are everywhere. These are from the solar system, and we identified their composition as typical, seen before, known. Only along the meteor path, we found those special type spherules, Belau type, that have the enhancements that I mentioned before. To me, that looks like a demonstration that indeed these are unique and special and not found elsewhere.
Now, what of the idea of getting more? In other words, instead of, say you're looking for the main mass, but would it be helpful to go back and drag the sled around and get an even bigger sampling of the spherules, and in order to get a greater characterization of this material? So is there any plans to just head back out and do the same thing and get an even greater sampling, or do you think you have enough based on what you found in this expedition?
Well, we have 700 of them and we analyzed only 57, so we still have many more to examine that will improve the statistics. But in principle, we can go back with the same expedition that will try to find the bigger pieces, and in the process of looking for bigger pieces, collect also the additional spherules, because now we can be much more efficient because we know where to find them. We made this map sort of like in a treasure hunt, and we could potentially harvest many more of them. So yes, that would be something we can do in the future.
Now, populations of interstellar objects, as I am one and I am two. So we should have a fair chance of finding more of this on land, for example, and finding objects within our meteorite collections that could be of interstellar origin. So is that the next step, is to start searching those kinds of databases and trying to determine if we actually already have other interstellar materials that we've recovered and didn't recognize?
Yeah, that's an excellent point. Indeed, there are many meteorites in private collections or in museums that were brought over the years, found. And we can go to them and check if any of them has the fingerprints that we identified for the first interstellar meteor, and that could be used to identify the statistics of impacts of things from interstellar space. Based on the fact that one such interstellar meteor impacted Earth per decade, because the survey was over a period of a decade, we had one, we concluded that only 1 in 1,000 impacts is of an interstellar origin, that you need to go through 1,000 rocks before one of them will be from interstellar space. So these are very rare compared to the rocks that originate within the solar system. It's simply because the Earth is situated in sort of the core of the solar system, where there are plenty of Lego pieces that were used to build up the planet, and they collide with Earth every now and then. Whereas the interstellar objects, they fill the entire space between stars.
So what can you envision the future of looking and studying interstellar materials is going to be? Can we get a characterization of the Milky Way galaxy at large much, much greater than what we can do through astronomical observation? So here we're up against observation versus experiment. And you can actually recover materials that you can presumably, it's sort of like a sample return mission. You can study a rock from Mars with a rover, but it would be much better if you returned it to Earth. So is that what we're dealing with here? Is that a much greater field will open up as far as characterizing planet formation and alien life, for that matter, in the Milky Way from here on out?
Yeah, so that allows us to have a census of the type of objects ejected from the vicinity of stars into interstellar space. And of course, some of them will be natural, some of them might be technological in origin, and we want to know what the mix tells us. And in particular, for natural objects, you have to understand that most of the material of protoplanetary disks that make the planets will not be ejected at high speeds or would remain bound. We don't know how much material was at the beginning of the solar system in rocks. And this can help us understand what early systems had and how many objects were expelled from them. And moreover, if there are some exotic environments that make much tougher rocks that move at a higher speed, like IM1, that would be new information that we haven't anticipated. And finally, with technological gadgets, it will just represent the history of civilizations over billions of years that launched crafts that left their planetary system and may have be not functioning anymore, but we could learn about their history. And I call that archaeology in space. That's space archaeology, similar to the way we learn about past cultures here on Earth that are not around anymore. So that could be a frontier. If we find technological objects, it could inspire us to explore space because we would learn about technologies that we never developed here on Earth. And maybe we would learn that there are smarter kids in our cosmic block that are much more capable than we are. And the way I think of this is it would be a wake up call for us humans to realize that we are all in the same boat, the Earth sailing through space, and we should work together instead of investing in conflicts on this rock that we were born on, which is pretty much what we are doing now. Right now, we spend about $2 trillion every year on military budgets. And I did the calculation that if we were to decide to live in peace with each other, rather than worry about how to kill others or how others may kill us, then we would have a surplus of $2 trillion a year, and that would be sufficient to launch a CubeSat towards every star in the Milky Way galaxy within this century. Billions of those within 1 century. If you imagine that, then you can understand that one civilization far away could have sent those probes if they were smart enough, intelligent enough, not to fight with each other and to invest in space exploration. So that's the kind of objects that I'm looking for, I'm seeking. When I was on the ship, I continued my morning routine. Every morning at sunrise, I jog for 3 miles, and I did it on the deck of the ship. And at one time, someone asked me, "It looks like you are running. Are you running away from something or towards something?" And I said, "Well, I'm doing both. I'm running away from some of my colleagues who have strong opinions without seeking evidence, and I'm running towards a higher intelligence in interstellar space." I should mention that I discuss the benefits to humanity from an encounter with other technological civilizations. In my book, Interstellar, I do not agree with warnings like the one expressed by Stephen Hawking a decade ago, saying that we should be careful. I think it will be to our benefit because we could learn from them. And I don't think they would worry too much about us as a threat to them because we are not that sophisticated. We just had our science and technology for 1 century and we are still developing.
Now, we have, in by luck, and perhaps it was responsible for us even being here with tides and things like that. We have the ultimate in a sled, like what you were dragging on the ocean floor, and it is the moon and interstellar objects. Could the moon be a repository of an entire history of the Milky Way galaxy, of preserved meteorites sitting on its surface that are of interstellar origin? And should, as we explore the moon and go back, should we actually pay attention to that we might actually have, an archive? The moon is an archive of interstellar objects, perhaps. And there's a precedent for this. When the Apollo samples returned to Earth, there was a carbonaceous chondrite. It was from the solar system, but there was a meteorite fragment that was recovered in the lunar soil. So is the moon an interstellar archive?
Yeah, so both the moon and Mars are museums because they don't have an atmosphere. I mean, Mars has a very thin atmosphere. So large objects simply hit the surface. They don't burn up in the atmosphere like you see on Earth in the case of meteors. And they collect on their surface everything that impacts them. And indeed, some of those impacts were associated with interstellar objects. So it would be worthwhile to survey the surface of the moon, the surface of Mars. And I did a calculation that, in fact, over the past few billion years, we know that Mars, for example, lost its atmosphere a few billion years ago. And before that, it had liquid water on its surface and could have had life as we know it. In fact, it's possible that life started on Mars before it did on Earth, and that we are all Martians because it was delivered to Earth by rocks, Martian rocks that carried the microbes in them. And if so, these were the first tiny astronauts that traveled from Mars to Earth. So when Elon Musk talks about traveling from Earth to Mars, nature did it before him and was represented by tiny microbes, not the scale that Elon wants to launch. And so it's possible that Mars had life before Earth. In fact, if life evolved into intelligence twice as fast as it did on Earth, then there could have been intelligent beings on Mars a few billion years ago, because it lost its atmosphere roughly in the middle of its life. In that case, I'm particularly interested in the question of whether we can find any signatures of that. And one calculation that I did was, suppose there were high rises on Mars, would any of them survive until now from a few billion years ago? And I calculated that every square kilometer was bombarded by more than the equivalent of 20 Hiroshima atomic bombs as a result of asteroid impacts. So, in fact, just think about 20 atomic explosions on every square kilometer of a city. Not much would survive standing. That's the way you should think about the surface of Mars, the surface of the moon. They were bombarded and everything was ground to dust. Structures would not stand tall. That's something to keep in mind. However, we know that Mars has caves, also the moon. These are called lava tubes, like you find in Hawaii. When lava is flowing on the surface, may develop a crust that creates a ceiling to that flow, but then underneath that ceiling, the flow continues, and then you end up with a cave. These are called lava tubes. And I'm particularly curious visiting the lava tubes on Mars because they are protected from the extreme temperature variations on the surface between day and night, which range in hundreds of degrees. And also the interior of the lava tubes is protected from cosmic rays that are bombarding the surface of Mars. So, if there was any intelligence there, or even developed animals, I would like to go down these caves and search for any skeletons, search for any wall paintings that might be there. And that can be done with a drone in principle that would go into them. Altogether, we did very little so far to search for signatures of life on Mars, and there is a lot to be done.
I always found that poetic that, when you think about that maybe when we colonize Mars, somebody should go down into one of those caves and make a painting and continue the traditions of Earth and start painting lava tubes with.
Well, what I'm saying is that there may be prehistoric paintings if complex forms of life evolved twice as fast as on Earth, because then by the middle of its lifespan, Mars would have had these prehistoric paintings there.
There exists, deep in the history of astronomy, a paper that suggested that there is one other area in the solar system, one other body that does have lava tubes and may once have had water as much as the rest of the members of the system do. And that maybe we should be looking perhaps for microbial life in the lava tubes of Io. Your views on that?
Well, that would be interesting as well. It's easier for us to explore the surface of Mars first, and actually the moon first, but we know the moon never had an atmosphere, and therefore it's unlikely that it had life in its history. So I think the easiest target for us first would be Mars, and then we can continue to explore beyond that. Frankly, I'm more excited about going beyond the solar system because, those environments are completely unknown. And I would like to, if I could live long, I would like to visit another star system. In principle, just theoretically, that's possible if you embark on a ship that accelerates at 1g, the kind of acceleration we feel here on the surface of Earth. And if you continue to move at 1g for a year, you reach the speed of light. And that would make your journey short. And if you continue to accelerate at 1g for 20 years, you cross the universe, actually, because you're moving so close to the speed of light. There is time dilation. Time passes much more slowly in your frame within that ship compared to the universe at large. So the only problem is that you need a huge amount of fuel in order to propel yourself at 1g. There is one caveat to that, and I'm exploring it right now with some collaborators. And Hermann Bondi, a physicist, came up with the idea about 70 years ago that if we can allow for a negative mass to exist. What does it mean, a negative mass? It means an object that instead of attracting other objects gravitationally, it actually repels them. So the mass is negative, just like we have positive and negative electric charges. In principle, that's allowed by Einstein's theory of gravity. So he said, let's imagine a negative mass and then put it next to a positive mass of the same value. What would happen then? Well, the positive mass will pull the negative mass towards it, but the negative mass will push away the positive mass away from it. So they will continuously accelerate together as a pair, and they will keep accelerating indefinitely and reach very close to the speed of light. And so this is an unusual engine because you don't need to invest any fuel in propelling it. In the context of the 1G travel that I mentioned before, you can just take an object with the mass of the Earth that is negative, put it next to Earth. We will just move at 1G and not feel anything unusual while crossing the entire universe in our lifetime. And so that is perhaps an illusion. I mean, maybe negative masses do not exist. We're now working on a scientific paper trying to see if it's possible to construct a negative mass. There is one example of repulsive gravity that we know about, and that's the vacuum in the present day universe. There is the accelerated expansion of the universe, which is caused by the repulsive nature of the vacuum mass density, and that is called the cosmological constant. The only question is, can we excavate that energy, dark energy or cosmological, can we concentrate it in a small region so that it will become a negative mass that is isolated? That's not clear.
Negative mass has much greater connotations, though, because there you can start to think about things like traversable wormholes and keeping them open, or anti-gravity by nature, or things like Alcubierre warp drives.
Well,
So that would seem to me, if you could actually create a negative mass material somehow, that would change everything.
of course.
It would change everything we know about the universe and what's possible.
Yeah, of course. And Newton would have seen his apple accelerating away from him rather than falling on his head when he studied gravity at the orchard of his family in England. Yeah, so of course it may well be that we can't really create a negative mass and that will resolve matters. But all I'm saying is, there could be propulsion schemes that do not require a lot of fuel, and they could bring objects close to the speed of light.
Now, Doctor, you have a new book out that you've mentioned, Interstellar, and tell us about that. What is it? What are the themes? What were you thinking about when you wrote that?
Well, interestingly enough, the title of this book is the punchline of my scientific paper from the expedition, that we found this meteor that landed in the Pacific Ocean almost a decade ago to be interstellar. But my book actually talks about the implications for humanity of finding that we have a neighbor. And I think, it would be the most important scientific discovery that humanity ever made. And that's why it resonates so much with the general public. But even in the House of Representatives, just a month ago, there was a hearing in which the word extraterrestrial was mentioned multiple times, because the government identifies a population of objects that it cannot understand. And so the question is, do they belong to an adversary that has technologies we don't fully understand, or perhaps they came from outside of this earth? And I think we should engage in seeking more evidence. That's what I do within the Galileo project that I lead at Harvard University. And we constructed an observatory that is operating 24/7 and looking at the sky in the infrared, optical, radio, and audio. And the data from it is being analyzed by machine learning software. And we're trying to see if all the objects we identify are birds, balloons, drones, airplanes, things that are familiar to us, or whether there is anything else. In that way, we are trying to help government. Anything that is human-made is boring as far as I'm concerned as a scientist. We would like to see if there's anything beyond that is technological from a superhuman origin. And, there is this biblical story in the Old Testament of Moses witnessing the burning bush that was never consumed. And that served as an experience that convinced Moses that God exists, superhuman entity. And if I were there, I would have taken the infrared cameras that we use in the Galileo project and observe the bush and tell Moses whether the surface temperature or the luminosity of this bush imply that indeed it's not natural and it may have been a sign of a superhuman entity. I do think that even for religious people, science can help in appreciating what the reality holds and whether there are true surprises. So it increases our awe. And if we do find a technological gadget from a very advanced civilization, it will bring us the same sense of awe that you find in religion, or that a cave dweller would feel visiting New York City and seeing all the flashing lights and the gadgets there. So my point is that a very advanced technological civilization is an approximation to God. And the more advanced it is, the closer it might look to us as in terms of producing miracles. It might produce life in its laboratory. It might even produce a baby universe in its laboratory if it knows how to engineer the unification of quantum mechanics and gravity. And perhaps the Big Bang originated this way. We don't know. That's the first question I would ask if I had a dialogue with extraterrestrials. I would ask them, what happened before the Big Bang? Because we currently don't have a theory that unifies quantum mechanics and gravity that predicts what happened before the Big Bang. And so I would like to know the answer, not only because it would reveal a new facet of physics that we don't have, but also because it represents our cosmic roots. I would like to know if our universe was produced by scientists in white lab coats. Just realizing that there is much more out there that we can learn by finding intelligent partners. We are late to the party. We could ask them how to join the class of intelligent civilizations. What do we need to do? It will give us a new perspective about our place in the universe. And we should search for it out of modesty. A lot of my colleagues argue extraordinary claims require extraordinary evidence, which is a statement made, repeated by Carl Sagan. But the point is, they're not seeking the evidence. And if you're not seeking the evidence, you will never find it. Gravitational waves would not have been discovered unless we invested decades and funded LIGO at more than $1 billion. Things just don't fall to your lap unless you are searching for them. We would never find materials from the meteor unless we went to the Pacific Ocean. So just saying it's an extraordinary claim that requires extraordinary evidence, that's not a good statement to make. What you need to realize is that extraordinary evidence requires extraordinary funding and effort. And without seeking the evidence, we will never find it. So given that this question of whether we have a partner is of great interest to the public and now also to government, scientists should engage in it. It should become part of the mainstream. And if we search, we might find it. The analogy is made between Enrico Fermi asking, "Where is everybody?" and a single person standing at home and saying, "I don't have a partner next to me." Well, of course you don't, because you need to go to dating sites, or you need to look through your windows, or at the very least, just step out of your home and check your backyard for anything that came from the street. Maybe you'll realize that you might have a partner out there because you received something in the mail from someone that might be your partner.
Now, if you find an alien civilization and you make contact with it, and as Arthur Clarke once said, any sufficiently advanced technology is indistinguishable from magic. So you find this, but could there be in this a profound disappointment where the alien says, "So what do you think happened with the Big Bang before 300 million years after?" And that the message is physics will always be incomplete no matter how advanced you are. Do you think we actually have a chance of actually understanding a complete view of the universe and cosmology?
Well, it will never be. It's always a quest, and life is a learning experience, and we should regard it as a process by which we enrich ourselves. and learn more about the reality that we all share. But very often the obstacle is that the humans prefer to believe in stories, in illusions that have nothing to do, no support from the reality that we all share. And you see that even in physics, where there are large communities believing in ideas that have not been tested, that will not be tested in their lifetime. So I think in order for us to really get better, we need to pay attention to evidence, especially anomalies, things that may indicate that we're lacking some understanding, and try to seek as much knowledge from the reality, not by putting goggles on our head about some virtual realities, even if they are much more flattering to us. And that's the biggest lesson I learned from the experience of Galileo Galilei and Copernicus, that were thinking ahead and were rejected at their time, and today they would have been cancelled on social media. The point is, we would never reach Mars if we believe that Mars is moving around the Earth, if the Earth is at the center of the universe. So it really pays off to adapt to the reality the way it is, rather than imagine it as flattering to us. And the latest incarnation of that is for us to believe that we are the smartest, that Albert Einstein was the smartest scientist who ever lived. That's obviously flattering to our ego, but it is unlikely to be true, because not only that I don't think that we are unique and special, because that's arrogant, and that we have so many billions of planets with conditions similar to those on Earth, but also, I don't think that we are behaving very intelligently right now. We are engaged in zero-sum games, the way we were when we started. When there was food that was limited, if one person gets it, another does not. So it's a zero-sum game. But what science brings to the table is a reality of abundance, where everyone gains from scientific knowledge. It's an infinite sum game. That's what people do not understand. And I think that's the mark of an intelligent species. Once it gets to the point where it stops engaging in zero-sum games and starts working on infinite sum games. And the way I phrase it in my book is that there are different classes of civilizations. We are sort of type D, that is destroying our environment, actually, if you think about climate change and the fact that we engage in conflicts. And type A is a civilization that really creates its own environment. So creates a baby universe that includes itself, but does it again and creates life, even though it represents life by itself. So that will be the highest level of intelligence, where you are able to recreate the reality in which you live. We have to aspire for that. And I talk about how important it would be for us to start recognizing the potential of getting better at what we do, and that is the only way by which we can survive in the long term, given all the risks, the existential risks that we face.
And everybody can find that book on Amazon or your favorite online retailer or the bookstore. Now, my last question for you, Dr. Loeb, for today, and we'll actually do perhaps a separate interview on Interstellar in the future. But for now, my last question is this. All right, life arose, and this is on the theme of the potential of life having originally arisen on Mars that we were talking about. But this goes further. Back then, when life appears on Earth, microbial life, abiogenesis, the sun was still nearer to members of its birth cluster. So, in a nutshell, my question is could we be of interstellar origin?
Yeah, in principle, there could have been an exchange of planets or rocks between stars when we were in a cluster, and that could have actually brought life to Earth, not from Mars, but from another star system. And we also wrote a paper where we calculated the chance of transferring life between stars, even if we are not in a cluster. That's possible. There is a lot for us to learn, and one way to do it is if we find other forms of life. If they happen to be clustered, then it's possible that panspermia was responsible for their spread, that they started at one point and then spread around it. Moreover, if we find life that is of the same type that we find on Earth, with the same DNA and double helix, and that would argue either that there is only one solution for life and that we find here on Earth, or that life was transferred. And the one thing about biology is that we are talking about self-replicating probes that were envisioned by von Neumann, but biology does it for free. The dandelion flower sends seeds that spread with the wind and carry the DNA. They are self-replicating probes. We don't have a 3D printer that can print a 3D printer. We don't even have a car that can heal when it encounters a minor accident. Whereas the human body can produce additional human bodies, it can also heal when you get a scratch. And so we have a lot to learn. The Wright brothers learned how to fly just 120 years ago. Nature did it for millions of years before that. And so what I'm saying is we should be humble, learn from nature, because it was capable of accomplishing the tasks that are still ahead of us. The human brain is using just 12 watts, and the large language models that we currently engineered that try to imitate the human brain through our artificial intelligence, ChatGPT and so forth, they consume like hundreds of thousands of times more power in the huge computers that they have to employ. And so somehow nature developed these very efficient ways of accomplishing the same task. And the human skull is limited in space just because it needs to go through the birth canal when a baby is being born. And so the fact that we have these computers packed in such a small volume that are capable of fantastic things that nature made out of nutrients found in the wild, that's something to be admired. I really salute nature. I enjoy nature every day when I jog at sunrise.
Nature is amazing and a constant source of entertainment and wonder. Dr. Loeb, we are out of time, and I thank you again for joining us today. And everybody should check out Avi's new book, Interstellar, and for that matter, Extraterrestrial, the one before that. And I hope you'll join us again soon for a discussion of your new book.
I will be delighted.
Event Horizon and my channel are now available as a podcast on Apple Podcasts, Spotify, and YouTube memberships. Early ad-free episodes, bonus episodes, and sleep-focused content. Sign up now by clicking the links below to your platform of choice.